Today we're going to learn about using equations to make tables and graphs. All right, so if I look here, I have this equation, y equals x minus 2. And so what I'm going to do is I'm going to take my x values, I'm going to plug them in for x and solve and get a y value. Well, that will give me an ordered pair and I can graph it. So let's start by plugging in the first value. If I plug in a 2 right here, that would be 2 minus 2. So I'm going to plug that in, 2 minus 2. Well, 2 minus 2 is 0. Okay? If I plug in a 3 right here, 3 minus 2 is 1. If I plug in a 4, 4 minus 2 is 2. If I plug in a 5, 5 minus 2 is 3. So now I have these ordered pairs and I'm going to write them right here. So I've got 2, 0, 3, 1, 4, 2, and 5, 3. All right, so these are the points I need to graph. Now I need to figure out what my scale is, and I'm just going to do that by looking at the numbers here. And I see that all my numbers are relatively small, so that looks like I'm going to be able to just count by ones. So here's where 0 would be. So 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. All right, so my first point is at 2, 0. Remember, the first value is your x value, and it tells you to go right or left. In this case, I'm going to be going right because all of mine are positive, so it's in quadrant 1. So over 2, and the second number tells me to go up or down. In this case, it's a 0, so then I just have a point right here. The next one says 3, 1, so I go over 3, and then I go up 1. Then the next one, over 4 and up 2, and over 5 and up 3. All right, and I'm going to connect that because I could continue this pattern on. And technically you could continue it the other way as well. Okay, so now we need a conclusion. So basically I'm just going to be describing the graph. So the graph is a line and it's sloping upward. And why is it doing that? Well, the graph slopes upward because my coefficient in front of x, even though I can't see it, would be a 1. And because my x coefficient is positive, the answer to my problem will continue to slope upward in this direction. So my conclusion would just be that the line slopes upward because x is positive. Now that doesn't mean I couldn't plug a negative value in for x, but what I really mean is the coefficient, which in this case is 1, is positive. Another thing that you might want to consider is this right here. If I were to have stuck a smaller number in, let's say 0, 0 minus 2, don't get tricked and accidentally put 2. If I have 0 and I take away something, I've now moved to the negative side. So you could also rewrite this as doing KCO as y equals x plus negative 2, okay? Both of these would mean the same thing. All right, so let's look at the second example. So I have y equals 4 minus x. Same thing, I'm going to plug in these values right here and solve and figure out what my y coordinate is. So if I plug in a 0 here, that'd be 4 minus 0. 4 minus 0 is still 4. If I plug in a 1, 4 minus 1, 4 minus 1 is 3. If I plug in a 2, 4 minus 2, well, that's 2. 4 minus 3 is 1. 4 minus 4 is 0. All right, and again, I'm going to label the coordinates or make the ordered pair. So that'd be 0, 4, 1, 3, 2, 2, 3, 1, and 4, 0. So let's graph these. Now notice I have all 4 quadrants, and this point right here is where 0, 0 would be. So again, I need to determine what should I count by. Well, again, I'm looking at my numbers and I don't see anything higher than 4, so I can count by 1s here too. So this would be 1, 2, 3, 4. This would be negative 1, negative 2, negative 3, negative 4. 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. All right, so 0, 4 means I don't move sideways, and then I just go up, so right here. Next one, 1, 3, 2, 2, 3, 1, and 4, 0. Okay, and then to connect these, and this would also continue on in both directions if I chose to plug in more values. All right, so now I'm looking here, and my conclusion, don't forget this is your x-axis and this is your y. Okay, my conclusion now, well, I notice it's sloping downward, but it is a line. If I do KCO like I did here, y equals 4, change that to plus, make x its opposite. You can see that x is a negative x. Or if I put a 1 there, it has a negative 1x, so it has a negative number as its coefficient. So when you have a positive x or a positive coefficient for x, it's going to slope upward. And when you have a negative x or a negative coefficient for x, it's going to slope downward. But they're both lines because we just have x. We don't have any exponents. Okay, so line slopes downward because x is negative. Okay, now we have one more. Now, these were all one-step problems, so now we have a two-step. Okay, so we have an exponent here, and we're subtracting 3. So we need to be really careful, and especially careful with how we solve these exponents. Okay, so we have -2. First, I'm going to fill in for the x. -2 to the second power -3. Well, be careful because that exponent of 2 means a -2 times another -2. Well, I know 2 times 2 is 4. And when we have a negative times a negative, that makes a positive, because again, I can just think, let's make a mad face right here. A negative and a negative makes a positive. So this would just turn into 4 minus 3, and 4 minus 3 is 1. Okay, so let's do the next one. -1 to the second power minus 3. Well, -1 times -1 is 1. So this would turn into 1 minus 3. Ooh, be careful. Don't tell me it's 2. Because if I have 1 and I take 3 away, I don't even have 3 to take away, which means I've gone to the negative side. So I can do KCO and change this. Okay, I can do it up here if I want. X to the second power, change that to plus. Change 3 to a -3, okay, equals y. Same thing. It doesn't matter if the equals y is at the end or if it says y equals at the beginning. All right, so I'm going to KCO this, keep the 1, change the minus to a plus, and make this into a -3. 1 plus -3, different sign subtract, would be -2. Okay, next one, let's plug in 0. So I have 0 to the second power minus 3. And 0 times 0 is 0. So that would turn into 0 minus 3, or 0 plus -3, which would just be -3. Okay, let's plug in a 1. 1 to the second power minus 3. Well, 1 times 1 is 1 minus 3, which is exactly what I had right here. So plus -3 would also be -2. I should get the same answer here. And 2 to the second power minus 3. Well, 2 times 2 is 4, minus 3 gives me 1. Now, notice I got the same value here and the same value here. So my ordered pair, -2, 1. Then I have -1, -2. Then I have 0, -3. 1, -2. And 2, 1. All right. Now I can definitely tell I'm going to have more than just the first quadrant like I did for these. And I need to look and see, well, what should I count by? What's my scale? Let's label this X and Y. Well, again, all my numbers are relatively small, so I think we're still okay to count by ones. So this is 0, so 1, 2, 3, 4, -1, -2, -3, -4, 1, 2, 3, 4, -1, -2, -3, -4. All right, and remember the first value tells me to go sideways. So the x, it has -2, so that means I go to the negative side, so -2. And then 1 tells me to go up, so right here. My next one would be -1, so I go over to -1, and then -2, so down to -2 would be here. 0 means I don't go sideways, I just stay there. And then -3 tells me to go down. And then 1, -2 would be here. And then 2, and then +1 would be here. And then if I connect those, it makes this funny shape, and this is actually called a parabola. Now, why did it make a parabola? Well, it actually made a parabola because of our x to the second power. This exponent of 2 causes the graph to bend like this. So, that's what we're going to say. We're going to say it was a parabola. Parabola. And we're going to say that because x has an exponent of 2. Okay guys, so really you're just plugging in values and solving. You just really need to make sure, number 1, that you're following order of operations, and number 2, that you're using integer rules. Same signs add, different signs subtract. Remembering to use mad face when you need to. All right, other than that, just be careful, and I'll see you next time.